Hi guys, I just wanted to review the notes from class today and then do one example in this video, and then you can start the homework. This is a better picture compared to what I drew in class. So if you want to change yours and make it nicer, this time you can actually see point P and Q. The blue line is the secant line, and the tangent line is drawn at point P when x is a. So eventually we're going to show how to find the slope of the tangent when x is a, which is point P, which is denoted by this pink line because that's the tangent line. So in reality, this distance should not be that far. Remember, in class, we want point Q to travel. We want point Q to travel along this curve and get really, really, really close to point P. And that's only going to happen if I shrink this distance. I want this distance to get smaller and smaller. And that's only going to happen if H gets smaller and smaller. So, again, I know I wrote this, so I'll be really quick. Slope of the secant line PQ is f of this y value minus this y value divided by this x value minus that x value, and the h is canceled. Please make sure you understand where this comes from. These two expressions are two y values being subtracted. A plus h is one x value. A is the other x value. And then when we subtract them, I get just h. Please understand that A represents the point of tangency. So when I go write down the slope of tangent line at x equals a, so at point P at x equals a, the slope of the tangent line involves you to evaluate this limit. And then the purpose of all that work in class, when we were finding, it's actually still on the board, the purpose of all that work in class, when we were finding all the slopes of those secants, the purpose was for you to see that I was getting all those random points to approach P. All these secant lines that you drew, and I'm sure your graph was messy, all the secant lines you drew, they were eventually going to get closer and closer to the tangent line. And on the board, that's when someone in class said that the slopes were approaching 2, so the slope of the tangent line was 2 for that example. Okay, I want you to understand where this comes from. I want you to understand why we're evaluating a limit of the difference quotient. And I want you to understand why we want h to approach 0. We want this h to go smaller and smaller, so these two get closer and closer. And if these two get closer and closer, the secant lines will get closer to the tangent line, and then we can find the slopes of the secants because they're going to approach the slope of the tangent. Okay, so here's an example. You can pause the video and do it yourself. That would be a really good strategy. So I want us to find, we're going to let f of x be 4 minus x squared. And task A, our first task is, let's go find the slope of f at x equals 1. I know you used 1 in class and I'm using 1 again, so I think we'll be okay. So let's do task A and then I'll show you what task B is. Before we get started, let's quickly just sketch this so we sort of have a feel of what's going on. This is just a quadratic, concave down, went up 4. This point is 2. And then our goal is to find the slope of the function at x equals 1. I'm going to eyeball, this is 1. So this is what the tangent line looks like. And our job is to find the slope of that line. The slope is downhill. Sorry, the line is downhill. The line is decreasing. So the slope will be negative. M will come out to be some negative answer, and I hope when I do that my work confirms that. So how do you find the slope of f at this curve? Slope of f at x equals 1. You find the slope of the tangent line at x equals 1 using this. So the limit as h approaches 0 of f of, again, my point of tangency, my A, my point of tangency here is 1. That's my point of tangency. F of 1 plus h minus f of h divided by, f of A divided by h. Before we start thinking about how to evaluate this limit, why don't we figure out what f of 1 plus h is? F of 1 plus h, this is my f of x. F of 1 plus h is going to be 4 minus 1 plus h, the quantity squared, minus f of 1. If I plug in 1 here, I get 3. So let's make sure we're okay with what's happening. All I did was find f of 1 plus h, and then I found f of 1 by plugging in x is 1. Alright, so my favorite way to evaluate a limit is algebraically. Direct substitution will not let h be 0. Again, tell yourself that I'm just evaluating a limit. All the limits we've seen, it has usually x as its variable, and these are x's. This time they're just using h's, just because. So we can't do direct substitution, so let's see if I can sort of simplify. If I can sort of simplify, let's expand that, and then maybe I can do direct substitution. Do you notice I keep writing limit as h approaches 0, limit as h approaches 0? If you can do the same thing, please. When I expand that, I get 1 plus 2h plus h squared minus 3 divided by h. Look, I still write the limit as h approaches 0, if you can also do that. When I distribute this negative and I combine like terms, 4 minus 1 is 3. The 3 and the minus 3 turn into a 0. This is a negative 2h. This is a negative h squared. Darn it, I still can't plug in h is 0. Let's keep simplifying. I promise that eventually, I'm hoping that all this hard work pays off and that eventually we can evaluate and plug in h is 0. Let's take out in the numerator, let's take out an h in the numerator, greater than common factor of h. I get negative 2 minus h divided by h. I'm so glad the h's cancel. Last step. I'm so glad the h's cancel because this is what my expression boils down to. Okay, this was all of this was the work to get the h's to cancel so I can do direct substitution. Here's my last step. I'm going to evaluate this limit. I'm going to do direct substitution. And when I do direct substitution, I just get negative 2. Right? For h, I just plugged in 0. Again, it seems like a lot because I showed every single step. I want you to realize that we are simplifying, expanding, distributing, greatest common factor, just so I can eventually plug in h is 0. The slope of my tangent is negative 2, and I predicted it was going to be negative, and I'm glad my work showed that it's negative. This is how you use the limit of the difference quotient to find the slope of the tangent at a given point. In this case, the given point was x equals 1. Okay, that's A. Here's question B. Question B wants you to find the equation of the tangent line. So, I promise all the hard work is done. This is the easy part. This was the hard work, to find the slope of the tangent or the slope of the curve to be negative 2. So this blue line, that's all they're asking. Go find the equation of this blue line. This seems like a task that you would do in like middle school. Go find the equation of a line. Remind yourself what you need to find the equation of a line. You need at least a point on the line. So my x is 1, and then my y value, again, this point where x is 1 is on the parabola, and it's obviously on the line. I need the y value, because I need an order pair. If I plug in 1 here, I already know f of 1 is 3. So this is the order pair, this is the point that's on the line, and I just did all this work to find the slope of that line. So these are the two pieces that we need to find the equation of the tangent line. I highly recommend that we do point-slope form. This is not the y-intercept, so let's not do y equals mx plus b. Here's my answer in point-slope form. That's it. So, told you this was going to be the easy part. The equation of this line that I drew is this. This work, which is calculus, shows the slope of that tangent line, which is -2. Please get in the habit of writing the limit as h approaches 0. Once you evaluate the limit using direct substitution, you obviously are done. Okay, thank you for watching. Have a nice weekend, and do the homework now, please.